How can material ever fall into a black hole? How could we dock with a rapidly rotating space station? And why have we never sent a microscope to Mars? All this and more in this week's Question Show. Hi everyone, welcome to the Question Show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I will gather them up and I will answer them here. And just a reminder, we record this show live every Monday at 5 p.m. Pacific time here on the YouTube channel. And while you're watching this, there should be a live event somewhere else on my channel for when the next one is going to be happening. And so you won't miss it. You should subscribe to the channel, click on the little notification bell, find the live event, ask yourself to be reminded, and I promise you, YouTube absolutely will remind you so that you'll come here with lots of time in advance. Or will it? All right, let's get into the questions. Adon Barion. How can black holes exist if their formation cannot be observed from the outside? All right, if you follow black holes and their event horizons enough, you've probably heard this concept that from an outside observer, as you're watching material fall down onto the black hole, it experiences time dilation. Again, we always use that example of Interstellar when the astronauts went down to the planet in orbit around the supermassive black hole. They spent a day on the surface of the planet, and yet when they came back out, the rest of the universe had experienced 30 years. And so they were experiencing time dilation. And so from the perspective of an outside observer, as material falls down closer and closer to the surface of the black hole, it experiences this time dilation. And if you're watching this material fall down into the black hole, over time, you'll see it move slower and slower and slower, and eventually it'll appear to just freeze on the surface of the black hole. And then it will start to redshift away, and it will just fade away. From the perspective of the person falling into the black hole, you see the universe around you speed up, and you're actually watching hundreds, thousands, millions, billions of years pass by while you're standing there or being torn asunder by the tidal forces around the black hole. And so this question a lot of people get is, you're looking at the black hole. How can the black hole increase in mass if the material that is falling down onto the black hole never reaches it? It's all a matter of perspective. And so the thing to really keep in mind is that a black hole of a certain amount of mass has a certain size of event horizon. And as new material falls down towards the black hole, mathematically, from an outside observer, the black hole gains mass. So say you have a black hole with 10 times the mass of the sun, and then you feed it a star, then the black hole will gain in mass by another star. And the event horizon around the black hole will expand outward because the size of the event horizon matches the mass of the black hole. And it will include that material that fell into it. From your perspective outside, you see this astronaut, star, whatever, falling into the black hole and sort of freezing up and fading away. But from the perspective of the black hole, as it's increasing its mass, as it's increasing the size of its event horizon, it's able to absorb this additional mass. And mathematically speaking, the black hole has this additional mass pretty much as soon as it falls near to the event horizon. I'm sure you've noticed this planet name pop up above my shoulder, and this is a way for you to vote on the questions that you thought were the best. This week, the winner was Mr. Alakido, question about microgravity versus zero gravity. And obviously, I'm practicing right now. I'm saying weightlessness, I'm saying free fall, and I'm going to try to not say zero G or microgravity, but we'll see how far I get. So congratulations, Mr. Alkido, and congratulations to me for answering the question. So you're going to see these planet names all the way through this episode. Once you've watched the whole episode, just go down into the comments down below and type the name of the planet that you thought was the best. We'll count up the votes and we will celebrate next week. Adam Klein. If we simulated artificial gravity on a space station by spinning the station really fast, how would we ever be able to dock to it to resupply or to be able to leave if there's an emergency? Would we even be able to go out and do repairs? Yeah, one of the ideas for being able to minimize the effects of weightlessness, of free fall in space, is to have the astronauts experience some kind of artificial gravity. Now, the ideal thing would be a constant acceleration where you're standing in a spacecraft, it's accelerating at 1g forever, and you would experience 1 gravity. But any spacecraft that we can imagine would run out of fuel long before you were able to go for more than a couple of minutes at 1G. So the other way to do this is to rotate your space station. And so engineers at NASA wrote some technical papers about this, and they did the math that if you had a space station with a 56-meter radius and it was turning 4 times a minute, then anyone who was standing inside the station against that outer wall would experience 1 gravity. But the problem is what's known as the Coriolis effect. And so if you are standing, your feet are experiencing 1 gravity, your head is closer to the center of the space station and is experiencing less gravity. And it would actually be pretty uncomfortable. Like, maybe you would get used to it, but there'd be a lot of really weird things that would happen. Like, if you were going to try to walk around on the inside of the station, you would have to lean one way or another depending on which way you're going and which way the station is going. Or if you wanted to pour your coffee, the coffee would come out of the coffee pot and follow this curved arc before it sort of made its way down. And so the way to fix that problem is to slow down the rotation speed of the station so that you're maybe only turning, say, twice a minute and you're experiencing something closer to, say, Martian gravity. And then the Coriolis effect would settle down. The other option, of course, is to make a much bigger space station. Why not make one that's kilometers across, hundreds of kilometers across? You know, in our imagination, these things can be as big as we want, but practically speaking, getting stuff into space is very expensive. And so these things will start out very small. But the question that you're asking is, how do you dock with one of these space stations? And the answer is that the space station will probably have a central core that doesn't rotate, that holds in one direction. And then it has this rotating structure that's around it that is rotating. And so as you are in a space shuttle and you're approaching the station, you will match your rotation to this central part. You'll dock with the middle of it, and then everyone will get out and you will be weightless in free fall in the middle of this central station part. And then you will have to have a way that you can then move out to the outer parts of the station. Maybe it'll be some kind of elevator, or maybe there'll be a ladder that you climb. And as you start out with not experiencing any weight, you'll then go up towards the exterior of the station and you will be being taken around by these spokes of this station, and you experience more and more gravity until eventually you come out into the larger station. And that's when you're now experiencing the full weight of centripetal and centrifugal force. Kazbingo the Great. Hey Fraser, this is a follow-up question to the Mandalore question and Viking experiments. Might it be a stupid question, but why not send microscopes on the probes to search for life? So far, a microscope has never been sent to the surface of Mars. And you think this would be an obvious thing to send. You know, if we're searching for past or present evidence of life, we can see there aren't any trees, there aren't any dinosaur bones sticking out of the surface of Mars. Any life that's going to be on Mars is probably going to be microscopic, the size of bacteria. And so we should send the right tool for the job. And yet so far, a microscope has never gone to Mars. And there's a bunch of good reasons for that. They're big, heavy, expensive, and really difficult to work with a robot on the conditions of Mars. But people have put together technical papers proposing microscopes. And there was a paper that I was reading just before the show today, and they proposed that you could send a microscope to Mars that would allow you to observe objects down to 1 micrometer. And again, to give you perspective, that is about the size of bacteria. And so you would be able to see bacteria on Mars today. The instrument would be about 5.7 kilograms, and it would use about 30 watts of power. And that would use up a big chunk of a future rover's science budget to be able to do this work. And when you think about the search for life on Mars, it's been this very careful process, going from step to step to step. With Spirit and Opportunity, they were like, was there evidence that there was ever water on Mars? Curiosity, was there water on Mars for a long time? Perseverance, was there water, and were there the conditions for life on Mars, the organic molecules, things like that? As they narrow in and find better places where you've got better evidence, then you can imagine future experiments, future rovers designed to answer very specific questions. And it might just be that the most efficient way to do this is when you send humans to Mars, maybe in the late 2030s, that they go with microscopes. The other plan is the Mars sample return mission, and that's what's happening right now. Perseverance is filling its belly with samples of the surface of Mars. It's then going to meet up with the Mars sample return mission, feed all of these samples over to that spacecraft. It's going to launch off the surface of Mars and bring those samples back to Earth, where scientists can study these samples in the largest possible, most sophisticated laboratories that humanity has ever created. And we could never stand a hope of delivering that kind of science capability to the surface of Mars. So it's incremental, and over time, as interesting discoveries are made, new solutions, new experiments will be sent to Mars or the other places in the solar system to try to uncover more information. Ryan Taylor, what happened to your fake backdrop? It used to be so pretty. If you go back to some of my original videos, I wasn't sitting in a room with a bookshelf behind me. I was out in the wild, in the Canadian temperate rainforest, the forest moon of Endor. And I'm still surrounded by the forest moon of Endor here on Vancouver Island. It's right there. I can see trees. I can see trees on the other side of this camera, but we don't film in it. And the reason is just it was so much work. I mean, we would have to go and gather up all of the camera equipment, all the sound equipment, find some place to go into the forest, shoot the videos. It was many hours of work, and then we would have to sort of bring it all back, and there would be mosquitoes on my head. There would be people walking past us on various trails we'd have to stop. There would be deer coming through, bird calls, eagles yelling, chainsaws, airplanes flying overhead. It was a mess. And so when we built this new studio that I'm in right now, like the goal was efficiency, for me to be able to create as much content as humanly possible. And so back at the very beginning, when we were doing that, we were putting out maybe 2 6-minute videos a week, maybe 1 6-minute video a week, and sometimes later on the question show. But now we produce the giant question show, we produce space bites, we produce multiple interviews, so we're able to generate a lot more content. That said, I mean, obviously I know that's like my brand, and the plan, hopefully when the good weather returns, is I'm setting it up so that I can sit outside just on the other side of the window where I am in my studio, and we'll be able to have that forest background behind me. You'll be able to hear the birds, and hopefully we can sort of find some happy place in between. So all hope is not lost for the return of the forest background, but at the same time, it's just like, do I want to make more content, or do I want to have trees behind me? 1-2. Hey Fraser, Earth was very lucky to be struck by Theia. A moon was created, we got an iron core, and it stabilized our rotational axis. Why did this not happen to Mars in their planetary collision? Not only did it not happen to Mars, it doesn't look like it happened to Venus, doesn't appear that it happened to Mercury, so Earth is quite lucky that we had exactly the right kind of impact that formed this large moon and, as you say, stabilized our rotational axis and did even more, potentially, to help encourage life on Earth. It probably created the tides. And when you think about the first life forms that were attempting to get out of the ocean into land, the tidal areas where you've got the water going in and out over top of the sand allowed the early life forms to be able to adapt to being able to survive on the surface of the planet. So yeah, we owe a lot about the state of life thanks to the fact that we got smashed by a Mars-sized object billions of years ago. So why didn't it happen to Mars? Well, it's possible that something like that did happen to Mars. And one of the big mysteries for Mars is its 2 moons, Phobos and Deimos. And they look very much like asteroids, but the evidence is building that they are not captured asteroids and that they are in fact chunks of Mars that have been blown off into space by an impact in the ancient past. And in fact, the Japanese are sending a new mission to Phobos in the next couple of years. And one of the big questions that they're going to try to answer as conclusively as possible is, were Phobos and Deimos pieces of Mars that got thrown off into space? When you think about our time that we live here in the solar system, we actually have a pretty big coincidence, a happy stance, which is that we get to see Phobos at all. Because Phobos orbits quite close to the surface of Mars, it takes less time to go around Mars than Mars turns once in its axis. And what this means is that the orbital height of Phobos is decreasing day after day, year after year. And the next, say, 50 to 100 million years from now, Phobos will get close enough to Mars, it'll get torn up into pieces, and those pieces will rain down on Mars, and then Phobos will be gone. And we think about the long history of the solar system, 4.4 billion years, we're in this tiny chunk near the end of Phobos' life when it actually existed. So maybe Mars did have a large object crash into it and form a large moon. And maybe Venus did too. And yet, like Phobos, the moon was too close to the planet and it crashed back down into it again. And that might help explain why Venus has a very slow rotation rate, why it rotates backwards from the rest of the planets in the solar system, and some of the other things that have happened to it after that. If you like my answers to your questions, as well as the other things that we do at Universe Today, consider joining our Patreon club. This allows us to keep minimum ads for everybody. Like, as you can see, there are no ads in the middle of this video. As a patron, you'll also get an ad-free experience on universetoday.com for life, even if you unsubscribe. You'll get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Daniel S., Rob, Lowell Hamilton, Zach McHugh, Greg Cole, Barry Reinhartz, Cyber D, Pat Watson, Michael Redden, and Rick Thor. Join the club at patreon.com/universetoday. 21S Mac, is it ever tough for you to get interviews or talk with NASA? No. NASA's terrific about this kind of thing. In fact, it's too easy. They're too helpful. So just to give you a little bit more behind the scenes on how we work here at Universe Today, my job as the publisher of Universe Today is that I'm out there finding the stories that the writers are going to be working on. Now, they're free to write on any story they want, but I also put a big queue of stories that kind of match my curiosity. And in many cases, it's sort of convenient to go after the stories that Fraser's found. And so when you look at Universe Today, a lot of the titles and the ideas for stories are coming from me. As I'm going through this process and as I'm figuring out which stories we're going to cover, I see really interesting stories that I want to find more information about. And so I will drop an email to the principal investigator or the press advisor that's associated with that story and say, "Hi, I'm Fraser Cain, publisher of Universe Today. I'd like to interview somebody on my YouTube channel about your research." And I would say 90% of the time I get a response saying yes. And, by putting out this press release, they're putting themselves into this mode where they want to be interviewed. They want to talk about what the research that they've done. They're trying to get publicity. And my job is to give them publicity. It is this, it's this perfect relationship. Where I find sort of less success is when I find some interesting paper like on Archive or like some other journal, and I'm really curious about it and I want to know more, and I'll reach out to one of the researchers and explain who I am. And I'd say I get maybe a 25% to 50% hit rate in those situations, which is too bad because a lot of times, I'm getting a scoop. Like nobody else is interested in covering this story out on the regular press. And I hope as you read Universe Today, as you subscribe to the newsletter, as you see what we talk about here on our channel, the interviews that I do, I'm hoping that a large percentage of them are stuff you've never seen anywhere else. And that's because I get so close to the source. But back to your original question, like NASA is great to work with. I mean, they have this really good infrastructure. every one of the research centers at NASA, at the Kennedy Space Center, at the Johnson Space Center, at NASA Glenn, at the Jet Propulsion Lab, they have a team of people who work in the press area who their only job is to be the glue between us journalists wanting to find out more information about a story and the researchers who work at NASA. And so a lot of the times I don't even bother going to the researcher. I'll just go straight to the press officer and say, can you put me in contact with someone who worked on this research over there? And they're like, no problem. And then a couple of days later, they've found the person. And the thing that's kind of amazing to me is that they will often like over deliver. And so like, I'm looking for somebody who worked on James Webb, and they'll give me Lee Feinberg, who is the director of optics for James Webb and Hubble Space Telescope and future telescopes. And you're just like, I'm not worthy, right? So, or they'll put me in contact with an astronaut or a Nobel Prize winner or whatever, but it's terrific. So I guess that's my advice to anyone who wants to be a journalist, wants to work on this kind of stuff, is go beyond regurgitating press releases, go beyond summarizing Wikipedia, reach out to the people that are doing this work, make contact, interview them, bring that material and that original new material that maybe nobody else has seen before, that you're now actually reporting news and you're not just getting there with the crowd and saying the same things that everybody else is. And I think until we got good at that, Universe Today didn't really stand out from the crowd. And now we're at this point where a large chunk of what we report on is unique, both on YouTube and on the web, and I'm really proud of that. So, nope, super easy to talk to people at NASA. Don Archangel, can GPT-4 or Chat GPT be a helpful tool for astronomers? I mean, I'm pretty deep into the Chat GPT rabbit hole at this point and have been playing around with this a lot. I probably spend 2 or 3 hours a day right now just prototyping and specking out and trying to understand how this works and what role it can play. And so like, I think it can be a helpful tool for anybody. I mean, like, they're not sponsoring me, but it's designing lower back pain mobility workouts for my wife and I. It's planning our meals for us to eat based on the ingredients that I have on hand. I've been using it for fixing my grammar for stories that I work on, and also as a brainstorming partner for thinking of ideas and bringing in additional pieces that maybe I didn't think of when I'm working on a story. And so I think that there is a role for kind of this sort of tool for almost any kind of creative work that people are doing. And I think, when you look online, there's sort of two camps. There's the one camp that says this is worthless. It kind of hallucinates, it lies, it forgets, it makes up references, and that is all completely true. And so it is not to be trusted. Like, when I look at the kinds of answers that I get out of these systems, I just sort of imagine, I look at it and go, you're lying to me. And so I trust, but I verify every single fact that these things tell me. And then on the other hand, people have this sort of like apocalyptic vision of that this is going to take away all the jobs, and it's going to come for the lawyers, it's going to come for the doctors, and in the end, only the baristas will remain. And I don't think it's that either. Like, I think the role that these play is as a tool. It's a fancy hammer that you can use as you do work. And we haven't really plumbed the depths of what this can do. And so, for example, if I was an astronomer, I wanted to do amateur astronomy, and I wanted to figure out what I was going to look at tonight, I might ask Chat GPT and say, it is March 20th. What bright objects can I see in the night sky tonight that I can look at with my telescope? And it'll give me a list of objects that I could see that I maybe wouldn't have occurred to me. And then I'd say, now tell me 10 more. And it would tell me 10 more. And they'd say, now tell me 10 more. And if you had a friend that you did this, they would just be exhausted, but ChatGPT just cheerfully gives you 10 more. And you can imagine with astronomers, like, they may be doing some kind of research and they've got some idea that they're had. And then they may ask it, like, do you know of any other examples, any other theories, any way that someone else has been thinking about something related to this? And then Chat GPT is going to dump out a bunch of ideas. Many of them could be lies. And so then the researcher has to look through them and then do some cross-referencing and go and check if these things are there. But it's a very powerful tool. So I think we're going to see this technology make its way into almost every aspect of human society and our lives, and quickly, shockingly quickly. And I think it really makes sense for anybody who wants to understand what role this is going to play is like, just start playing around with it. Sign up for a Chat GPT account and just muck around until you've got your head wrapped around how this might play a role in your life, how you can use it, and also how people might be using it against you. Like, it's a good way to sort of vaccinate yourself against it. Sam Powell, why are we tiptoeing around these icy moon planets and not just cutting to the chase? Sending a submersible with LED lights and a video feed already. I want my space whales. We all want space whales. I mean, obviously, seeing the European space whales feeding magnificently under the ice on Europa would be wonderful. And I can't wait to see that video footage. But there's a lot that's complicated to get to this point, being able to actually do that. Europa probably has a liquid ocean under this vast ice sheet that's tens of kilometers thick. So it could be 20 to 100 kilometers thick. That's very thick. It's very hard to get through. But we don't even know how thick it is. And it might be that the water is liquid in various pools and fissures that come closer and closer to the surface of Europa. And so the first thing that NASA is going to do is they're sending this spacecraft called the Europa Clipper, and it's equipped with a ground penetrating radar system that will allow it to scan the interior of Europa, ideally down to the ocean, and map out the interior structure of the moon and see, is it a solid shell of ice that extends for 80 kilometers, or are there cracks and fissures and ponds and pools and underground lakes, maybe some of which are really close to the surface? And if they are really close to the surface, like, maybe you could just land right next to one and just have your spacecraft just crack a few centimeters of ice and dig up a little bit of this water and do some samples and tests on it. Maybe you'll see a space whale breach right there. But if once we've got that information, once we understand the terrain on Europa, then the next engineering challenge is to figure out, how do you get through it? What is the best way to do that? And I've done tons of episodes on this. I've interviewed several people that are involved with this. There's like one of the Nyack interviews that we're going to probably be releasing next week, where it's a new kind of fusion reactor that would allow you to bore through the ice on Europa. But the best idea is that you put some kind of nuclear powered heat probe onto the surface of Europa, and then it just melts its way down through the ice, spooling a wire behind it as it goes until it reaches the water, opens up some pod bay door, and out come a bunch of little submersible bots that zip around in the water and transmit their data back to the mothership. And then it uses that wire to transmit data back up to some kind of surf. There's a lot of moving parts there. It's very complicated. So there's no easy cutting to the chase. There is research to be done. There are missions to be sent. We have to understand new technologies to be developed before we can finally get a view of those European space whales. But I promise, I pretty much call NASA every day and nag them to build these missions. So I'm on it. Unmasked and anonymous. What trends or driving forces can you foresee helping to increase public interest in space exploration efforts in the next 25 to 50 years? I get this question a lot. People ask me, why are people so interested in space now, but they weren't 5 years ago, 10 years ago, 15 years ago, whatever? And I always reply that people have always been interested in space. It's funny, I will be at a party or at some kind of social gathering, and people are like, what do you do? And I'm like, I'm a space journalist. And they're like, oh, I love space. And I'm like, well, of course you do. Everybody does. right? If there's one thing every human being can agree is that we love space. That's why science fiction movies are so exciting. Obviously, the revolution that's happened in the last couple of years is the rise of reusable rocketry. Things like what's happening with SpaceX, where you see these rockets take off, the booster stage goes and lands out of the ocean or lands back near the launch facility, and you see what's happening with Starship and these fully reusable two-stage rockets that are going to potentially decrease the costs to get into space by an order of magnitude. That's all really exciting, but I don't think the general public is ever going to care about space exploration the way you do, the way I do, the way the people who watch this channel do. There's probably more people who are interested in knitting than are interested in space exploration. There's a lot of things that human beings can be excited and fascinated about, and we all fall into our various silos and watch our content. And I think as space exploration becomes more routine, the general interest in it will wane. How many people are out there excitedly talking about airplanes flying from continent to continent? Well, probably more than space. I don't know. There's probably a lot of airplane spotters, train spotters, more than there are rocket spotters. But still, as we move beyond this being this incredible first accomplishment, the first time a human being sets foot on Mars, like after a while, it's all just going to become routine and nobody's going to really care. It'll just be the background hum of humanity, the way all of the other things are that we do. So I don't see there will ever be an increase in public interest in space exploration. There will just be a lot more space exploration because the cost will come down, because the technology will improve, because we'll come up with more and more cool things to do with space, and it'll just be part of our lives. So don't try to make it happen. Like don't evangelize space. That's my job. No, don't evangelize. It's fine. Everything's proceeding nicely. Things are moving, and we will eventually get to that solar system spanning civilization one way or the other. James Ryan, are there any serious plans to make use of Starship's immense lifting capability in the next 5 years? No. Serious plans? No. Let's go with the best possible version of the launch of Starship. Like, March is now out, so maybe I'm not able to see the future, but maybe Starship will launch in April. And let's say that it works. Let's say that the thing launches to space, the first stage returns back to the launch pad, is caught by Mechzilla, the upper stage flies to orbits the planet for a couple of times, and then returns to Earth, lands safely. And I know that's not the plan. I know the plan is they're both going to soft land in the ocean, but let's just say it works. Then within a year or so, this thing could start flying, carrying satellite payloads into orbit at a dramatically decreased cost. Well, within a couple of years, Starship will gobble up the entire launch market for existing satellites. Every mission that is planned on some other platform will be put on a Starship and sent to space. Then you've got the ideas in the works that could use Starship, like the human landing system for the moon. You've got V2 Starlinks that Starship will be able to be filled up. And so we're going to get these constellations of Starlinks grow, and they'll probably provide similar services for competitors to Starlink. I know that will suck. But then what? Then you're out of things to launch. And the hope is that we will come up with new ideas for things to launch, like much bigger space telescopes or orbital refueling facilities. But even those are the kinds of things that are sort of in our imagination today. What gets exciting is when the costs of access to space come down so far, then our imagination comes up with brand new ideas, things that had never occurred to us before because it was just impossible, that now enter the realm of possibility. And so after 5 years, I think that's when we'll start to see the beginnings of what's possible with a fully reusable two-stage rocket system that is relatively inexpensive and able to launch hundreds of tons into low Earth orbit and refuel in space and head off to the moon and Mars and Jupiter and who knows. So it's so hard to predict things that are, there's this term, the technological singularity. And so we are potentially entering the space exploration singularity, where reusable rocketry, and whether it comes from SpaceX or whether it comes from Blue Origin or whether it comes from the Chinese, like this is the direction this is all going to go. And my imagination can't conceive of what the future might hold with launch costs coming down that far. David L. Hamilton: if one were to travel faster than light, wouldn't you overcome the light that passed you? Hence, you would see the image from behind, now in front, going in reverse. If you take the equations from Einstein for relativity, for traveling through space, and you put in the speed of light, then the time it takes to get to your destination from your perspective becomes 0. And if you put in faster than the speed of light, twice the speed of light, 3 times the speed of light, then the time it takes you to get to your destination is a negative number. So you arrive at your destination before you left, which doesn't make sense. Like, the math breaks once you get to the speed of light. So we don't know any way that you could move the speed of light. Obviously, there's the Alcubierre concept. There's other concepts that have been sketched out on how we might move faster than the speed of light. But the reality is that, according to the laws of physics as we understand them today, there's no way to be able to reach the speed of light or go beyond the speed of light. And so these kinds of questions, it all depends on how you want to implement your faster than light drive. And this is where you would want to look to science fiction. Yeah, if you use a warp bubble and you leave Earth and you fly several light years away from Earth, and then you look back, you would see Earth in the past from before when you left. If you travel fast enough, you could see the dinosaurs on Earth. So a lot of this stuff just turns into weird, head-scratching paradoxes and violations of the laws of physics as we understand them. And, we can't say that we will never discover warp drive, but like, one of the things is that when we look out into space, we don't see warp drives. We don't even see spacecraft moving slower than the speed of light. But you can imagine, like, if spacecraft could move faster than the speed of light, then they would get here from around the entire universe, from tens of billions, trillions of light years. They'd be able to make their way here. So yeah, unfortunately, the laws of physics as we understand them today don't allow us to really imagine what it would practically be like to move faster than the speed of light. All right, those are all the questions that we had today. Thank you, everyone who asked questions in the YouTube comments, everybody who showed up at the live show. Remember, we do this every Monday at 5 p.m. Pacific time. Come hang out. It's a lot of fun. And don't forget to vote. Pick the question that you like the best. All right, we'll see you next week. If you want to stay on top of all of the important space news, join my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There, you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast, or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to David Giltonen, Modsu, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verbeoff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us.